This video is about finding the value of k that makes a function continuous. But before we move into that kind of example, we need to examine the three-step continuity test. Okay? One, f of a, and a is just that number that is common in the constraint, and we will look at that some more as we move into our examples. If f of a is defined, meaning that when you evaluate the function at that number that is common in the constraint, if you get an actual number as your result, then it exists, it's defined. Okay? Or two, if the limit of f of x as x approaches a, and as we said before, a is that common number, if it exists, meaning that if the limit of f of x as x approaches a from the left side, that's what this negative means, is equal to the limit of f of x as x approaches a from the right side, that's what the positive means. If both sides are equal, then it exists. Okay? And finally, if the limit of f of x as x approaches a from both sides, which is talking about this part here, if it is equal to f of a, which is this original thing here, then for sure the function continues at that particular number a. Let's look at an example so this thing can make more sense to us. Alright, example 1. It says, find the value of k that makes the function continuous. Now, as we said before, a is that number that is common in the constraint. This is your constraint. And this one is a little straightforward because we just have one number, the same number in both constraints. Okay? So it means then that once you're finding the value of k, you're using the second rule, which is this. The limit of f of x as x approaches a from the negative side equals to the limit of f of x as x approaches a from the positive side. Whenever you are finding the value of k or the value of any variable that makes a function continuous, you will always be using this function here. Okay? Alright, so let's put it into practice. So we identify that our a value is 5. So it is the limit of f of x, and f of x in this case, from the left side, it's talking about the sign that is pointing to the left. So this one is pointing to the left, we're using this function. So it's the limit of x squared as x approaches 5, which is our a, from the negative side. Okay, that means that we're going to put 5 in this function here. So this would be 5 squared, and 5 squared is 25. Okay, now if it continues, then we're going to approach this thing now from the left. So this was from the left. Let's take it from the right now. This is the limit of f of x, but we're looking at the function where the inequality sign is pointing to the right. This is pointing to the right, so that is from the right hand side. So we're using this function here. So it is the limit of x plus k as x approaches 5 from the right hand side. Now remember that it approaches 5, so our x value is 5 here. Okay, so this would just give us 5 plus k. Remember, if it continues, then the left side must equal to the right side. And our left side was 25, so that would be 25. It must equal to our right side, which is 5 plus k. So let's solve for k. Solving for k, we're simply going to subtract 5 from both sides. So 25 minus 5, that is 20, equals k. And that would be your value there. Okay? Let's look at a second example, just to make this thing a little bit more clearly. Okay, so the second example, it says we should still find the value of k that makes a function continuous. Again, if we look at this, we have 0 in this constraint. We don't have any 0 in this constraint, so that would not be our a value. We have 2 in this constraint, and we have 2 in this constraint. So because 2 is common, then that is our a value. So we are coming back to our formula here. The limit of f of x as x approaches a from the left side, that must equal to the limit of f of x as x approaches a from the right side. Again, we say that the left side is talking about where the inequality is pointing to the left. So this is saying that x is less than. So less than is going to the left. X is less than 2. So we are working with this part here. So this would be our left hand function. Okay? For this part, it says that 2 is less than or equal to x, or we could read it as x is greater than or equal to 2. So we can rewrite this thing as x is greater than or equal to 2. Now we see that our sign is pointing to the right. So we know that this function here is for our right side. So let's complete this question now. So this thing is the limit of f of x from the left side would be this function. So that would be k, limit of k times our a value is 2, because that is the number that is common in here. So that is k times 2. As x approaches 2 from the left side, so this would just give us k times 2, that is 2k. It must equal to, let's take it from the right side now. From the right side is when the sign is pointing to the right, which is this function. So it would be the limit of f of x in this case would be this function, 3 times x squared, but our x is 2, okay, as x approaches 2 from the right. So 2 squared, that is 4, 4 times 3, that is 12, okay. So the fact that it continues, this side must equal to this side here. So it would be 2k equals 12, and to find k we divide both sides by 2. So k equals 6, and that would be our solution there. I hope this thing is a little bit more clear to you. Have a great day.